Rekha, Assistant Professor, Department of Mathematics. So today I am going to explain the steps in the simulation. So simulation is nothing but then we are going to have a mathematical equation and then physical form of an equation. So we can generate it for the next 15 days. We have simulated the next 15 days using the random numbers. The steps is nothing but we have to identify the measures of effectiveness and choose the appropriate set of random numbers. Determine the probability distribution of each variable and consider a random number as a decimal number of the cumulative probability, and finally we can simulate the values so generated into the formula. So let us see the first problem based on the simulation. In this problem, a sample of 100 arrivals of a customer at a retail or sales depot is according to an following distribution. The time arrivals is given and corresponding to the frequency is also given: 0.501, 1.52, 2.53, 3.54, 4.55. Frequency is nothing but 2, 6, 10, 25, 20, 14, 4, 7, 4, 2 is like that they have given. The study of the time required to service customer by adding up the bills, receiving payments and placing packages yields the following distribution. And the time between the service is nothing but 0.51, 1.52, 2.53, and the frequency is nothing but 12, 21, 36, 19, 7, 5. We have to estimate the average percentage customer waiting time and the average percentage ideal time of the customer by the stimulation of the next 10 arrivals is given. So, first of all, in this problem we have to frame the tag numbers for the each event. For example, if the arrival rate is some frequency and the probability one cumulative frequency, next we have to frame the tag number. The arrival number is given as 0.5, 1.5, but we have to generate it for 5 minutes. So frequency is also they have given, and how will you find the probability? Probability we used to find it as 2 by 100. So we get 0.02, 2 by 6 by 100, 0.06, and like that we can find all the values. And the probability, cumulative probability is nothing but 0.02. Next 0.06 if we add we will get 0.08, and 0.08 we will add with 10 means 0.18. 0.25 we add it as we will get 0.43. 0.20 we will add it as 0.63, and so on. We can find the cumulative probability by adding the probability of each value. Then after that we have to frame the tag number. How will you frame the tag number? If it is 0.02 means initially 00 to 01, and 0.08 means 02 to 07, 0.18 means 08 to 17, 0.43 means 18 to 42. Similarly, we can generate it for 98 to 99. And the service rate is random, 0.51 frequency. So for the service rate is also we have to calculate the probability and the cumulative probability, and we have to go with the tag number. So here the probability is 0.12, 0.21, 0.36, 0.19, 0.07, 0.05. The cumulative probability is 0.12. 0.21 means we have to add it with 0.12, and 0.33. 0.36 means we have to add with 0.69. 0.19 means we have to add 0.88, and 0.07 means we have to add it as 0.95. 0.05 means we have to add is 1. The tag number is 0, 1, 11, 12 to 32, 33 to 68, 69 to 87, 88 to 94, and 95 to 97. The random numbers are generated and linked to an appropriate events. The first 10 random numbers stimulated arrival, and the second 10 stimulated service time appropriate for this. And using the arrival rate and service rate, the service start time and the end time can be calculated. So each we can calculate it for service is nothing but 2 minutes. The inter-arrival minutes are there. So totally the service ends with, if it is 4 minutes means 6 minutes, because 2 minutes is nothing but an arrival rate, and we have to calculate it. It is 8.5, and each 1.5 will get an completed arrival right time, so we will get a 10 minutes, and like that and so on. We can calculate the start time and an end time of the service time. So how many minutes a server have to wait means, so each server has to wait it for 4 minutes, because 4 minutes they have to start means next 4 minutes customer server have to wait. because at each 4 minutes the customer will arrive. So like that we have to calculate the service time and the waiting time, and so the average waiting time is 0.7.0, and there are the total number of customers is 10, means 7 divided by 10 equal 0.7. The average waiting time per customer is 4.5 by 10, so we'll get 0.45. So like that we can calculate the average waiting time and the waiting time for the customer. Thank you.